For decades, medicine has really been built on the science of biostatistics, this idea of the average patient. But the future of patient care, well, it's personal. And that means we need a whole new toolkit, artificial intelligence. So in this explainer, we're going to bridge that gap between the statistical methods we all know and the AI tools that are already starting to reshape how we diagnose, treat, and care for individuals.
And there's a really good reason we're starting with this quote from Hippocrates. Because whether we're using a p-value or a predictive algorithm, the goal is always the same: to better understand the unique person sitting right in front of us. If we can keep the patient at the center of everything, that's the real key to navigating this huge technological shift.
All right, so here's our roadmap for today. We're going to start with what doesn't change, the doctor's central role. Then, we'll quickly revisit the power of biostatistics before exploring exactly why we need these new tools. From there, we'll break down AI into its different flavors, and finally, see how it all comes together in a modern doctor's toolkit.
Okay, first up, the constant. And honestly, this is probably the most important point in this entire discussion. No matter how sophisticated or powerful the tools get, the physician is, and absolutely must remain, the final clinical and moral arbiter. Period.
You hear all this hype, right, from healthcare companies, from big tech, about transformation. But let's just be crystal clear. The physician is the constant. Everything else we're about to talk about, it's simply a new set of tools in their bag, tools designed to empower them to better serve their patients.
So let's talk about the tool that has been the foundation of medicine for, well, over a century now: biostatistics. This is the language we've all learned to use to build real, solid evidence.
At its heart, what is biostatistics? It's really about turning simple observations into hard evidence. It's the framework we use to prove that a treatment actually causes an outcome, to measure just how big that effect is, and maybe most critically, to quantify our own uncertainty around any clinical decision.
Think about the huge questions it helps us answer. Does this new therapy actually work? How big is the benefit, really? Can I take the results of this big clinical trial and apply them to my specific patient? Biostatistics gives us the p-values and confidence intervals that really form the bedrock of trustworthy, evidence-based medicine.
Okay, so if biostatistics is so powerful and so fundamental, why is this huge push towards AI? Well, it's because the kinds of questions we're asking and the kind of data we have are fundamentally changing.
This slide right here really gets to the heart of the matter. Biostatistics is brilliant for studying the average patient, using clean, structured data with just a few variables. But modern medicine is all about the specific patient. We now need tools that can handle messy, high-dimensional data. We're talking images, clinical notes, genomic data, to make dynamic, real-time predictions about an individual's personal risk.
So let's open up that new toolkit. The first thing to understand is that AI isn't just one thing. It's really a catch-all term for a set of tools that have very, very different capabilities. And this is just so important. We can't really evaluate or implement AI effectively if we treat it like some single mysterious black box. To use these tools responsibly, we have to understand their different flavors and what each one is actually designed to do.
All right, flavor number one is machine learning. I want you to think of this one as the predictor. While traditional statistics is often focused on explaining why something happened, machine learning is laser-focused on predicting what will happen next. It's fantastic at finding patterns in data to answer questions like, what is this specific patient's risk of being readmitted?
Next up, flavor number two, deep learning. Let's call this one the perceiver. Now, this is where things get really interesting, because deep learning adds a new and incredibly powerful capability: perception. It can learn these complex representations from data, so it can see patterns in a radiology image or understand the context in clinical notes. It goes way beyond just numbers. And finally, our third flavor is generative AI, or the synthesizer. This tool uses its deep understanding of all those patterns and all that context to actually create brand new, relevant content. It can help draft a discharge summary, summarize the latest medical literature, or even suggest possibilities for a differential diagnosis. This table pulls it all together quite nicely. You've got machine learning, which predicts from structured data, like an early warning for sepsis. You have deep learning, which perceives patterns in messy stuff like images and signals for radiology analysis. And then you have generative AI, which synthesizes new information, like drafting clinical notes.
Each tool has a very distinct and powerful role to play.
So, the big question is, how do all these pieces, the old and the new, actually fit together in the hands of a modern physician?
Okay, here's the crucial point. It's not a replacement, it's a partnership. Biostatistics grounds us in solid evidence answering the question, what is true based on past populations? AI helps us look forward, providing prediction and perception to answer what might happen to this specific patient right now. A modern doctor needs to be fluent in both. So what this really means is that the physician's role has to evolve. You still have to be statistically literate to judge the evidence from a clinical trial, but now you also have to be AI aware to correctly interpret the predictions coming from a model. And most importantly, you have to be the clinical expert who synthesizes all of it to make that final decision and take responsibility for it.
So let's boil it all down. AI is here to inform our decisions, to augment our abilities, and to accelerate our workflows. It can automate the tedious stuff and find patterns we might miss. But what it cannot and what it should not ever do is replace clinical judgment, accountability, and the human reasoning that happens at a patient's bedside.
And this brings us right back to where we started, full circle. Because these tools are only going to get more and more powerful. The fundamental challenge for our generation of medicine, it won't be a lack of data or a lack of technology. It will be our wisdom to make sure that every new tool, every single algorithm, and every prediction we create ultimately serves the one true constant, the patient right in front of us.